Discovery encouraged the theory that the sun could not cause warming and that carbon dioxide must be the driving force. While direct changes in solar energy output may not be sufficient to cause the warming, there seems to be other factors at work. It has been known for some time that there is a high correlation between the length of the solar cycle and the Earth's temperature. An emerging theory seems to fit all the data and offers a far better explanation for the current warming than greenhouse gases. It has been known since the 20th century that there appears to be a correlation between cosmic radiation and low elevation cloudiness. The more cosmic radiation, the more cloud formation. Several Danish scientists led by Hendrik Stevensmark confirmed that relation in the early 1990s and found the correlation to be highly significant. They then developed a working hypothesis. When a sun goes supernova, it emits a burst of cosmic radiation. As that radiation reaches the Earth thousands of years later, it interacts with atmospheric atoms and frees electrons, which then act to bring water vapor molecules together, which finally condenses out into water droplets in the lower atmosphere, which creates clouds. Low elevation clouds are highly reflective and reflect the sun's energy back out into space. The more clouds, the more sun is reflected, and the less solar energy actually gets to the Earth to warm it, and the Earth temperature drops. As long as the cosmic rays are bombarding the Earth in high amounts, there will be greater cloud formation, greater solar reflectance, and cooler global temperatures. However, as the sun becomes more active with solar flares and other activity, plasma made up of charged particles of mainly electrons and protons called solar winds stream out from the sun. While this has many effects on the Earth, it keeps more of the cosmic radiation from reaching the Earth and other planets, thereby reducing cloud formation. With fewer low-altitude clouds, more of the sun's energy reaches the Earth's surface where it causes heating and a warming Earth. The effect is huge. In just 5 years, it can cause a 2% decrease in clouds, which in turn equates to an increase in surface warming equivalent to about 85% of what is claimed for all carbon dioxide warming since the Industrial Revolution. In addition, Mars and other planets in the solar system also appear to be experiencing global warming, just like Earth. Although the theory is in hot debate within the scientific community, this evidence supports the solar-caused global warming theory and further weakens the carbon dioxide greenhouse gas theory. Elevated levels of carbon dioxide may not be as harmful as Al Gore and other man-caused global warming proponents would have us believe. In fact, there is strong evidence that elevated carbon dioxide may be very beneficial, something that we are never told.
CO2 has been part of the planetary atmosphere since the first day this Earth evolved. And the plants and virtually everything we see evolved in a period of time when the CO2 level was very much higher than it is today. CO2 is something the plants love. They take up CO2, they use it, they give out oxygen. We take the oxygen and give out CO2. So it's hardly a pollutant at all. It's quite a naturally occurring gas that appears in our atmosphere and is very important to sustaining life on this Earth.
In terms of the broad geological perspective, the carbon dioxide concentration of the atmosphere right now is low. Almost all the plants that we live with and depend upon for food evolved in an atmosphere when the CO2 was higher in the atmosphere, much higher than it is today, and higher than we could possibly get it even if we tried.
Well, as a matter of fact, there were times when life flourished on Earth. The time when CO2 levels were something like 10 times current levels was when the dinosaurs were running around.
If carbon dioxide levels were 10 or more times what they are today, where did it all go? A look at how carbon is distributed today provides an easy answer. The atmosphere today holds less than 800 billion metric tons of carbon, soil and vegetation over 2,000, fossil fuels 4,000, and oceans nearly 40,000. However, the greatest sink for carbon is in sedimentary rocks like limestone, which has an estimated 80 trillion metric tons of carbon that has been taken out of the atmosphere. That is 100 times the amount that is currently in the atmosphere.
Yeah, some scientists believe that 9,000 or so years ago, agriculture sprung up all over the world. We saw people domesticate plants in Southeast Asia, and Asia, and South America, and Europe, and North America, all at about the same time. And it also corresponded when the carbon dioxide levels had increased from about 200 parts per million to about 250 parts per million. And it gave agricultural plants a competitive advantage over weeds. It may be that carbon dioxide is the reason we domesticated plants.
When we've looked at the literature on experiments that have been done with increasing levels of carbon dioxide, What we basically find is that most plants respond the same way. More carbon dioxide gives us more biomass. So if we look at a forest, a rangeland, a marsh, a wetland, or an agricultural field, what's really happening with more CO2 is that you have more plant material produced.
Increased CO2 worldwide, with few exceptions, means plants grow better, period.
We grow vegetables at 2 till 4 times the outside carbon dioxide level. That means between 700 and 1400 parts per million. We are growing all the vegetables that commercial growers are growing, but the main products are cucumber, tomato, pepper, eggplants, squash, lettuce and radish. The results of growing at elevated CO2 levels are a more rapid growth, earlier maturity, larger fruit size, greater weight, and a greater total yield of about 25%.
Increased yield is experienced in all food crops when carbon dioxide is increased. Research shows that a doubling of carbon dioxide increases food production dramatically. For instance, a doubling of carbon dioxide will increase cereal crops by 20 to nearly 50%, legumes like peas and beans by 44%, roots and tubers by 40%, and vegetables by 33%. As if that's not enough, carbon dioxide also helps these crops overcome harsh growing conditions such as drought and pollution.
The amount of water that's used by plants to produce the same amount of growth actually decreases with increased CO2.
So a higher water use efficiency means we're using CO2 more efficiently in terms of the water requirements for the crop.
This will change some of the ecosystems. It may allow some plants to grow in areas that now would be considered marginal for the growth of those plants. So we'd have more biomass production, plants in a little bit different area, and we may actually be able to farm some of the areas that would now be considered desert.
Rather than a dangerous pollutant, carbon dioxide could be called a miracle gas that acts like a free fertilizer to help alleviate famine in regions of the world that have frequent droughts and famines, all without causing harm to the environment or people.
Okay, research has shown that increases of CO2 concentration of 2, 3, 4, 5 times would not have a detrimental effect upon the Earth's biosphere.
We go up to about 1500 parts per million. That has no negative effect on human health. To get negative effects on human health, you have to go much higher. That's higher than 5,000 and 10,000 parts per million, at least. Looking at rising levels of CO2 from the viewpoint of the plant, that's no problem at all. We will have a higher production.
The evidence that increasing carbon dioxide in the atmosphere is going to cause a disaster is somewhere between slim and none. However, the evidence that it's doing a good thing by lengthening the growing season and making plants grow better is somewhere between lots